Hi guys, welcome back. Today we're doing contains duplicate 2. So we're given an integer array called nums and an integer called k, and they want us to return true if there are two distinct indices I and j in the array such that nums at I equals nums at j, and the absolute value of I minus j is less than or equal to k. So in example 1, we're given this input array nums and k equals 3, and we would output true because basically, so if we go through here, and for every index, so if I is 0 and j is 3, right, then we want the values to be equal. So nums at I equals nums at j. So nums at 0 is 1, nums at 3 is 1. So these values are the same, and then we want I minus j. So 0 minus 3 is -3, and then we take the absolute value, which is 3, and that would be less than or equal to k, which is 3, so we would output true. In example 2, we're given this input array and k equals 1, and we would still output true because we can just take the same indices, right? So like at I equals 0 and, no, we cannot. We can take these two indices because k equals 1. So if I is 0, 1, 2, and then j is 3, then the difference here is going to be 1, which is less than or equal to 1, and these values are the same, so we can output true. In example 3, we'd output false for this input array because, as we can see, so if we, there we go. So if we check each index, so from 0, or like for the ones that have like the same values, right? So like we can kind of skip some of the work. Then at 0 and 3, we have the same value, but the window is too big, right? Because we need k to be 2. And so the difference here is going to be 3, so that doesn't work. And then if we check the next one, then this is still a difference of 3, so that doesn't work. And then this is still a difference of 3, so that doesn't work. So we don't have any windows here that would work, so we would output false. So basically in this one, we just want to loop, or kind of, like we can add each of these elements in our, like keep track of each window at one time, so like however big k is, so in this case k is 3, so we can keep track of 3 elements at one time, and whatever element we are currently at, so like then we'll like loop through the rest of the array, right? And then we'll check like if we already have that element in here, so like let's say we have 1, 2, and 3, and we can keep track of that in a set. So let's say we have 1, 2, and 3. And then we are looping through like, then like once we get to index 3, then we will check if we already have a 1, because that's the current element in our set. And if we do, then we'll check for the, then we can just straight up return true, because, yeah, because then basically like if we don't have this element, then we'll add it to the set. If we do have it, then we'll return true, and then we'll just like keep our set updated. So like as we go through, then like let's say this 1 was not part of it, or like doesn't work, then like we would keep going, and like if there was more elements later or something, then we would remove the 1 and then just like add this 1 instead, and then keep going. Does that make sense? So like if I take example 3 instead, because that might be a little bit more clear to see what's going on, then our set would just be 1 and 2 because k equals 2, so we would add just the first 2 elements, and then when we get to 3, then we don't have a 3 in here, so we're going to add 3, but now this is too big, right, because this is bigger than k, so we're going to remove 1, and then we'll keep going. Yeah, that's right. So we'll basically keep doing that until we either reach the end of the array and there's nothing, in which in that case we'll return false, or we do hit an element and then we'll just return true. So we'll start by initializing our set. So we'll keep track of integers. We'll call it window. Then we are going to loop through and add our elements as we need. So Then, so if we already have this element in our set, then we can return true because that means it works with our window, because if it didn't work in our window, then it wouldn't even be in the set anymore because we would have removed it. So if window dot contains nums at I, return true. And then if not, then we'll be adding it. So then we will remove whatever element we need to remove if it's too big of a window. So if window.size is greater than k, remove nums at, and then we'll do I, because that's the current element we're at, minus k. So that'll be like k elements back from where we were, which is going to be the first element in our window. So then once we do all that, then we can just return false, and that should be it. Oops. Sorry, this should be outside of the for loop. My bad. Okay. Then our time complexity. So let's take a look. So we just have this one loop here, and then everything in here is constant. And then in this loop, we are iterating through n times, where n is the number of elements in our nums array. So our time complexity is going to be O of n, where n is the number of elements in nums. Then our space complexity, so we just have this hash set, and we are only storing k elements in the set at one time, because as soon as it gets bigger than k, we remove the first element. So it's always going to remain a size of k. So this is going to be O of k, where k is just the window size that we're given. That's just this k here. So that's it for this problem. Thank you guys for watching, and I'll see you guys next time. Bye!